Hello guys, this is CodeNCode and this is another lecture of this graph theory series. And in this lecture we are going to study about how we can calculate subtree size of a given tree in big of n time. That is, we are going to use DFS. So the problem statement is you are given a tree and we have to construct an array called subsize, where subsize of v stores the size of subtree rooted at node v. So what does that mean? Suppose we are given a tree something like this, then we would create an array subsize where subsize of 1 would store size of the subtree rooted at node 1. So the subtree size when node 1 is root is this. Subtree size of 1 is 4. So if you see, all these nodes which come under node 1 would be contributing into its subsize array. So the size of subtree rooted at node 1 is 4. Subtree rooted at node 2 is size is 3. 2, 3 and 4 are part of subtree rooted 2. So subsize 2 is 3. Same goes for 3 and 4. Node 3 and 4 contain one element in their subtree. So node 3 contains one element, node 4 contains one element in its subtree, node 2 contains 3 elements in total in its subtree, node 1 contains 4 elements in its subtree. That is why subsize 1 is 4, subsize 2 is 3, subsize 3 is 1 and subsize 4 is also 1. So the question is how we can calculate this in big of n time or simply using an array, a DFS. So let's take this tree as an example, so you know what this is if you are following the lecture series. This is adjacency list of the same graph. This is visited array and this is subsize array. Initialize with 0. 0 means size initially is 0 and visited is 0 because none of the nodes are visited till now. If you are following this series, you know what we would do. We would simply go and run a test on this, and then I'll show you the code, that this is the code, how this works. First we take a test case and then we proceed to look at the code and understand the code. But for now let's do it another way. So what we are going to do is we are going to define a DFS function which returns the size of the subtree rooted at node node. So what it does, if you make a DFS call to DFS5, then it would return the subtree size of node 5. Subtree size of node 5, yeah. So subtree size of node 5 is 1 because in subtree of 5 there is only a single element. And yep, whenever you are going to calculate the subtree size, it is important then that there is the tree is rooted. That is, there must be a root defined for the subtree. For example, if you consider node 1 as root, then all these become children of node 1, and then same goes for this complete subtree become children of node 2 and so on. But now if node 2 becomes the root, then node 1 becomes child of node 2, and then the subtree size changes. So subtree size changes along with the root. So it is important when you are going to calculate the subtree size of each node that the tree is rooted, or you must define the root. For our case, we are going to take node 1 as the root. If we take node 1 as root, then subtree size of 4 would become 3 because there would be 3 elements in the subtree of node 4. Now DFS, whenever you would make a DFS call to some node, then it would return the subtree size of that node. Okay, so if I'd make a DFS call to node 3, then it would return 2. The DFS 3 would return 2 because there are 2 elements in the subtree of node 3. So how it would be calculated? First, the return type of DFS is integer because it returns the subtree size of that node. First thing that we would do, we would also always do that is we would mark that node as visited. After marking that node as visited, we take the current subtree size as 1 because whenever you land on a node, that node itself is part of its subtree. So that is why there must be at least one element in its subtree. That is why we initialize the subtree size, current subtree size, to be 1. After that, we would make this is what we are doing. We are traversing the adjacency list of that node and traversing each child. If the child is already visited, then it have to be the current node's parent, because suppose you are traversing for node 4, you are traversing adjacency list of node 4, then since 1 is root, so you must be coming to node 4 from root via its parent. And who is its parents? Of course, node 2. So in the adjacency list of 4, there would be 2, 5 and 6, and if the node is already visited in its subtree, then for example 2, for in the case of 4, then 2 must be its parent. So we would not make a DFS call to its parent but its child. So if the node is visited, then we would not make a DFS call to that. Otherwise, if the node is not visited, that means it must be in its subtree. So if I am traversing the adjacency list of 2, and in the adjacency list of 2 there would be 1, 3 and 4, and when I would encounter 1, the 1 would already be visited, because you can reach node 2 only if you start from, if you have already visited 1, because there from root to node 2 you must traverse its parent to reach the current node. So 1 must be visited, so 1 would be visited, so we would not make a DFS call to 1. And then we would see that 3 and 4 are unvisited. And when you see the nodes which are unvisited actually lie inside the subtree of this. So 3 and 4 lie inside the subtree of node 2. Same goes for node 4. When we would traverse the adjacency list of node 4, we would encounter 2, but 2 would be visited because it is its parent or ancestor. Now 5 and 6 would be unvisited because those are children of current node, that is node 4. So subtree size of a node or a current node can be calculated from subtree size of its children. So suppose we have to calculate subtree size of node 2. If you already know subtree size of 3 and 4, you can easily calculate for 2. All you have to do, add the subtree size of 3 and 4 into your subtree size, and along with plus 1, because you have to add this node as well. So subtree size of node 3 is 2, subtree size of node 4 is 3, so 2 and 3 becomes 5, and then you would have, or you would add 1 as well for this node, so it will become 6. So subtree size of a current node can be calculated from subtree size of its children. So that is why when we traverse current node's adjacency list, suppose for 2, first we would encounter 1, but 1 is already visited, so it cannot be its child, so we don't have to make DFS call to there. But the another node would come out to be 3. So what we would do, we would make a DFS call to node 3. And what does DFS do? The definition of DFS in this case is that the DFS, whenever made a DFS call to some node, it returns the subtree size of that node. Bingo, that is what we want. For node 2, we want the subtree size of node 3. So what we would do, we would simply make a DFS call to node 3, or basically we would make a DFS call to that child. In this case it would be 3. So DFS of 3 would return the subtree size of 3, so we would add it into the current size of node 2 subtree size. After that, in the adjacency list of 2 there is 4, so we would make a DFS call to node 4 as well. So DFS 4 would return the subtree size of 4. We would take that and add it into the subtree size of 2, that is current subtree size, and then the current subtree size would become 6, because DFS 3 would return 2, DFS 4 would return 3, and current size is already initialized with 1, so current size will become 6. After that, what we would do, before returning that, because adjacency list of 3 contains only 3 elements, after that we would come out of the for loop, and then what we would do, we would update the subtree size of current node, that is node 2 in this case, it would be updated with 6, and then we would also return its size, so that its parent can utilize the information that my current subtree size is 6 and add it into its subtree size and calculate its own subtree size. So this is how it would work. Now this was all about theory, so let's test this on this sample test case. So this is in DFS, as we know, it would return the subtree size of the current node. Now since node 1 is the root, so we would make a DFS call to node 1. So first thing what we do, we make it as we mark it as visited, and then current size of the subtree would be initialized with 1, as we have seen in the code. After that, in the adjacency list of 1 there is 2, so we would make a DFS call to node 2 and ask it what is your subtree size, and whenever it returns its subtree size, all we have to do is add that into our current. So as soon as we reach node 2, we would mark it as visited, and also node 2's current would be 1 as well. Now in the adjacency list of 2 there is 1, but 1 is already visited, so it cannot be children of node 2. Now we would move on. There is 3, so in the so we would make a DFS call to node 3. So 2 would make a DFS call to node 3. Whatever it returns, it would add into its current. Now we are on node 3, so we would mark it as visited, and node 3's current would be 1 again. In the adjacency list of 3 there is 2, but 2 is already visited, so it must be its parent. Then we would move on to 7. Since 7 is not visited, hence we would make a DFS call to node 7, and whatever 7 returns, current of node 3 would be updated accordingly. So as soon as we reach node 7, we would mark it as visited and initialize its current to be 1. In the adjacency list of 7 there is only 3, but 3 is already visited, so 3 have to be its parent. Now since we have traversed the adjacency list of 7, so current is the actual subtree size of 7, so we would update the subtree size of 7 to be 1, that is the current, and then we would return 1 to node 3. As soon as we return 1 to node 3, 3 would update its current, and we would basically add 1 to it, so 3's current would become 2. Now in the adjacency list of 3, we have traversed 7 as well, and there is nothing left, so this must be the subtree size of node 3. So we would update the subtree size of node 3 to be 2, and then we would return 2. When we would return 2, DFS 2 would update its current, and that would become 3. And now in the adjacency list of 2, we have completed a traversal of node 3. Now we would move on to node 4. Node 4, since is not visited, so we would make a DFS call to node 4. Its current would be initialized with 1. Now in the adjacency list of node 4 there is 2, but 2 is already visited, so it have to be its parent. We would move on. Then node 5 is not visited, so we would make a DFS call to node 5. Its current would be initialized by 1, and 5 would be visited. In the adjacency list of 5 there is only 4, and 4 is already visited. So after completing the execution of adjacency list of node 5, this must be the subtree size of node 5. So we would update the subtree size of node 5 to be 1, and then we would return 1 to node 4. So node 4 would update its current, and then in the adjacency list of node 4 there is 6. So we would make a DFS call to node 6. Node 6 would be marked as visited, and its current would be updated to 1 or initialized with 1. In the adjacency list of 6 there is only 4, but 4 is already visited. So the adjacency list traversal of node 6 is completed. So this must be its final subtree size. So we would update the subtree size of node 6 to be 1, and finally we would return 1 to node 4. Node 4 would update its current, and then in the adjacency list of node 4 the traversal is completed. So this must be its subtree size. So it would update its subtree size to be 3, and then finally it would return 3 to node 2, which would update its current to be 6. And then since the adjacency list traversal of node 2 is also completed, so 6 must be its final subtree size. So before returning, subtree size of 2 would be updated, and 6 would be returned to node 1, which updates its current, which would become 7. And since the adjacency list traversal of node 1 is completed as well, 7 must be its subtree size. So we would update subtree size of node 1, and then it would return 7 to the function which had made a call to node 1, and which would be our main function. In our main function we can it is up to whether we save the subtree size or not. So after execution of the code, this would be your subtree size array. So it is as easy as that. If you are having any problem to understand this, just go through the video once again, or take your pen and paper, write down some extra test cases and try to dry run the code there. And for this I'm also providing the code in the description, so you can just check out that code. So thank you guys for watching, and yep, keep coding till the next video drops. Thank you.